everyone, welcome to today's class. We will learn about the second method for handling pipeline leakage. Leak sealing under pressure. Traditional methods for repairing pipeline leaks, such as welding or component replacement, which are often impractical for continuous production processes, and may not be permissible for flammable or explosive media. Leak sealing technology under pressure allows sealing and stopping leaks, while maintaining continuous production and operation, avoiding shutdown losses. Clamps are the most commonly used specialized tools for eliminating low-pressure leaks, often referred to as pipe clamps or fixtures. Standard clamps are split into two halves and consist of steel or stainless steel pipe clamps, sealing pads, for example, lead plates, asbestos rubber sheets, and fastening bolts. They are cost-effective, easy to install, and suitable for low-pressure conditions, generally below 2 megapascals. During use, first position the clamp near the perforation and thread the bolts, ensuring the clamp can move laterally with moderate force. Gradually shift the clamp to cover the leak point. Then tighten the bolts to secure it. The thickness of the sealing pad, for example, lead plate, must be moderate. Too thin to compensate for gaps, too thick to compress fully, hindering effective sealing. Factors such as leak location, medium pressure, and temperature must also be carefully considered. Next, let's watch a video on the operation of a split clamp.
Pipe clamp under pressure leak sealing. Under pressure leak sealing, fully known as pipeline and container non-fire, non-stop transportation, rapid under pressure leak sealing. This technology originated in the UK and has been used domestically since 1984. Under pressure leak sealing technology uses appropriate seals to completely cut off the medium leakage channel or increase the fluid flow resistance in the leakage medium channel so as to form a closed space and prevent fluid from leaking out. For under pressure leak sealing, first observe the on-site leak point. Analyze the causes of pipeline leakage and select an appropriate leak sealing method. There are multiple causes of pipeline leakage. First, weld defects. During welding, defects caused by human factors and other natural factors, such as cracks, incomplete penetration, incomplete fusion, slag inclusion, pores, and so on. A large proportion of leaks in welds are caused by welding defects left during the welding process. Second, corrosion. The pipeline system is corroded under the action of corrosive media. Environmental factors and stress, which thins the pipe wall, causes local perforation of the pipe and leads to leakage. Third, erosion. When high-speed fluid changes direction, it exerts large erosion force on the pipe wall, gradually thinning the pipe wall. For example, leakage caused by erosion often occurs at the elbows of steam pipelines. Fourth, vibration. Strong mechanical vibration or the impact of fluid hammer, air hammer, or water hammer makes the pipe material bear alternating loads, resulting in fatigue cracks and leakage. Vibration can loosen the connecting bolts of flanges, reduce the sealing-specific pressure on gaskets, and expand defects in pipeline welds, eventually leading to serious leakage accidents. Fifth, pipe material defects. The pipe itself has small sand holes and cracks, which are not obvious initially. After a period of operation, the defects expand and cause leakage. Pipeline leaks mostly occur at connectors and pipe sections. Leakage at flanges, connecting threads, valve bodies, and packing belongs to pipeline connector leakage. Leakage at welds, elbows where fluid changes direction, tees, and corrosion holes belongs to pipe section leakage. The two most common types of leaks are flange leakage and pipeline weld leakage. Common leak sealing methods are the tapping-plugging method and the clamp method. The tapping-plugging method uses a pointed hammer to directly tap the leak point, squeezing the leak point around to achieve sealing. This method is particularly effective for stainless steel pipes. The clamp method uses a clamp clip to lock the gasket at the leak point. To achieve sealing and pipe clamps, half-hole joints are commonly used. The pipe clamp has a simple structure, consisting of two main bodies, two rubber gaskets, and matching bolts and nuts. Currently, pipe clamps on the market have various shapes, which can meet the actual needs of different leakage positions. For leaks at the weld of a pipeline system T, pipe clamp under pressure leak sealing is adopted. Operating steps. First, risk identification. Conduct hazard analysis based on the chemical properties in the pipeline pressure and temperature. Second, select and wear appropriate personal protective equipment. For flammable liquids, anti-static work clothes must be worn. Third, select appropriate tools, such as explosion-proof wrenches, and the pipe clamp of corresponding size. Fit the two main bodies of the pipe clamp at the leak point and tighten the nuts. Note that the rubber gasket of the pipe clamp should be closely attached to the leaking pipeline. Two people cooperate to tighten the bolts diagonally in 2 to 3 steps, with the bolts facing the same direction. Fourth, recover tools to the designated location and clean the site. Pipe clamp leak sealing is easy to operate, can greatly improve work efficiency, and is widely used.
Clamp injection sealing method involves forcibly injecting a sealing sealant into the cavity formed between the clamp and the outer surface of the leakage area under external force. This rapidly addresses complex leak defects. When the injection pressure significantly exceeds the leakage medium pressure, the leak is forcibly stopped. The sealing sealant maintains sufficient working sealing pressure and transitions from a plastic to an elastic state within a short time, forming a rigid yet flexible new sealing structure. To achieve free sealing, first, fabricate a split steel clamp based on the leak's geometry and secure it over the leak. Use a high-pressure injection gun to inject the sealing sealant into the cavity between the clamp and the leak. When injection pressure exceeds leakage pressure, the leak stops. Once pressure stabilizes, close the injection valve to complete the sealing. Wedge plugging method uses ductile metal, wood, or plastic materials to plug leaks in holes, cracks, or gaps under pressure, based on the leak size and shape. Select a dry red pine wedge or bamboo stick, chopstick, dry branch, tapered from front to back, typically 60 to 100 millimeters long. Rub the wedge's tip with PTFE tape, then coat it uniformly with chloroprene rubber paste. Drive the wedge into the leak hole using a hammer. Saw off any protruding part and complete temporary sealing. Reinforcement methods include applying pipe clamps, adhesives, or fiberglass wraps for additional security. Cotton soaked in adhesive can be pressed onto the wedge before insertion. Steel band winding method employs a steel band tensioner to tightly wind a steel band around a sealing pad or adhesive at the leak point, stopping the leakage. This method is simple, easy to master, and suitable for pipelines or flanges with pressure below 3 megapascals, diameters under 500 millimeters, and smooth outer surfaces. Its drawback is limited elasticity. Now, Let's watch a video about flange steel band screw injection sealing operation.
Flange steel band screw injection sealing. During patrol inspection, field operator Xiao Wang found that the sealing surface of a flange on the cooling water pipeline had developed a controllable leak due to long-term exposure to material corrosion, vibration, and other factors, resulting in decreased mechanical performance and reduced elasticity of the pipe flange. The company is currently not in a scheduled maintenance shutdown period and needs to perform emergency repairs to quickly restore production. Based on the actual situation, the steel band screw thread injection sealing method was selected for this emergency repair operation. Required tools: vernier caliper, G-clamp, screw injection valve, steel strapping, steel strap buckle, tensioning tool, strapping cutter, sealant injection gun, fiber sealant rods, hex key wrench, fixed wrench, open end wrench, box end wrench. The sealant injection gun assembly includes hydraulic pump, triple gauge manifold, pressure gauge, quick connect coupling, manual lever, reset button, injection nozzle, high pressure hose. Required personal protective equipment: anti-slip gloves, safety shoes, safety helmets, pipeline transfer system, inlet pipeline, outlet pipeline, return line, storage tank, pump, gauges and control valves. Practical training steps. First, measure the diameter of the connecting bolts at the leaking flange using a vernier caliper. The measured value is 16 mm. Second, select an M16 screw injection valve. Third, secure the G-clamp onto the leaking flange using an M16 box and wrench. Fourth, loosen and remove a bolt from the flange using an M16 box and wrench. Fifth, take the M16 screw injection valve and align the flat side, non-step face against the flange. Sixth, tighten the nut with an M16 box and wrench, then remove the G-clamp. Seventh, loosen the set screw of the steel strap buckle using a hex key wrench. Bend one end of the steel strap and thread the buckle onto the strap. Eighth, wrap the steel strap around the pipe once, leaving some slack. Ninth, thread the steel strap through the tensioner's flat nozzle. Then press down the compression cover to prevent strap slippage. 10th, place a steel strap shim beneath the strap buckle. 11th, turn the tensioning handle gradually to tighten the strap. 12th, after sufficient tensioning, lock the strap buckle to prevent disengagement. Then, trim excess strap with strapping cutters. 13th, mount the injection gun onto the screw injection valve. 14th, install the manual lever onto the injection gun. 15th, insert the fiber sealant rod into the gun's packing chamber. 16th, tighten the gun's relief valve clockwise. 17th, pump the lever repeatedly to force sealant through both threads into flange gaps until leakage stops. 18th, loosen the relief valve counterclockwise to retract the plunger to its original position. Precautions. First, the threaded nozzle and quick connect coupling of the injection gun are prone to damage. Handle with extra care during use. Second, position the heavy-duty G-clamp near the loosened bolt and tighten securely. Third, for each sealant injection, fully discharge all sealant from the gun barrel chamber before resetting the piston plunger. Fourth, maintain a smooth surface on the plunger rod. After each operation, promptly remove any adhered sealant or residue from the rod surface. Fifth, verify the plunger rod has fully retracted to its original position before disconnecting the quick release sealant cap. Sixth, maintain safety awareness during operations to prevent lacerations from steel strap edges.
Today, we learned about leak sealing operations under pressure. During the process, prioritize personal protection. Select appropriate sealing methods based on field conditions. And safety must always come first. Strictly adhere to laboratory safety regulations.